In this video, we are going to prove this famous formula v is equal to u plus at. First, understand what this equation is. Here, v denotes the velocity at any time t. U is the initial velocity, means at the time when your motion started. And here, a is the acceleration. And mind it, this equation you can use only if your acceleration is constant. And if the acceleration is not constant, you are not going to use this. And to prove this formula, we are going to use two methods separately. First one is using graphs and second one is using calculus. So let's move towards the first method by using graphs. Here I'm going to use the acceleration time graph for its proof. But let us first look at this graph and understand it very clearly. Here, since we have acceleration is constant, so this line is going to be parallel to the x-axis. And the information we are going to use here, that the area under acceleration time curve is going to give us the change in velocity. Mind it's not velocity, linear change in velocity. And the same I have drawn in this given graph. So our main thing is to find the area. And as we can see that it's a rectangle. And the area of the rectangle is simply, we can see that it's the length into its width. Here, if we look closely, our length is from this point to this point, which is t. So I'm going to write it as t. And its width is acceleration a. So I'm going to multiply it. So we have got our a as a to t. And since we know that our area is change in velocity, so change in velocity is final velocity minus initial velocity, which is going to be equal to a times t. V final we have taken as v, and v initial we have taken as u, which is equal to a into t. So from here, we got our formula, which is v equal to u plus ap. So this is the first method in which we can prove this. There is one more method, which is by using calculus. So look at that also. So to prove this using calculus, we are going to use the formula here that acceleration is equal to dv by dt. This is a general equation. This we can use anywhere. We don't have to worry about whether the acceleration is constant or acceleration is variable. This is a universal formula. dv is equal to a dt. And now I'm going to put a derivation on the both sides. So on the right hand side, if I take I as 0, so at t equal to 0, our velocity was u. And at t equal to t, our velocity we have taken as v. Now look carefully. The integration of dv is simply going to be equal to v. And its range is from u to v. And on the right hand side, since the acceleration is constant, so I can take it outside, and dt is the time. So we have got power t, and the range from 0 to t. Mind it, if the acceleration is not constant, we will not be able to write this. We cannot take the acceleration now comes integral. But since here, acceleration is constant, so we are okay to go with it. So the next one, on the left hand side, we have v minus u, and on the right hand side, we got a into t. So here we got our formula by using both the methods. Thank you so much.